Hi, I'm Kate Scott, filmmaker, literacy advocate, and pre-law grad. This story time is also brought to you by the Young Artist Academy. This is a continuation of one of my younger memories at the LA Times Festival of Books. This book is called Voyager, an adventure to the edge of the solar system. It is written by American astronaut Sally Ride and Tam O'Shaughnessy. This book is for older kids than the last one that I read, though I think everyone can enjoy it. It's also a great chance to learn about the late Sally Ride. I was in awe of her when I met her in 2005 when this came out. Cool trivia about Sally Ride is that in 1999, she appeared as herself on the Touched by an Angel episode called Godspeed. It's one of my favorites. I hope you watch it too. So, let's do this. This is the story of two spacecraft, Voyager 1 and Voyager 2. They were launched from Earth to explore 4 distant planets: Jupiter, Saturn, Uranus, and Neptune. Earth is the third of 9 planets that circle the star we call the Sun. Jupiter, Saturn, Uranus, and Neptune are the 5th, 6th, 7th, and 8th planets in our solar system. They are very, very far away. Even when Jupiter is closest to Earth, it is 400 million miles away from us. Neptune is 3 billion miles away. All 4 of these planets are very different from Earth. All of them are huge. In fact, they are so big, they are called the giant planets. None of the giant planets have solid ground to stand on. They are made mostly of hydrogen and helium, the lightest gases in the universe. As you move into the planet, the gas gets thicker and thicker until it is so thick it becomes a liquid or slush. The first 2 giant planets, Jupiter and Saturn, are like each other in many ways. Jupiter is the biggest planet in the solar system. More than 1,000 Earths would fit inside of it. Saturn is nearly as big as Jupiter. Uranus and Neptune are also very much alike. They are not as big as Jupiter and Saturn, but both are much, much bigger than Earth. Because they are so far away from the Sun, they are cold, dark planets. Scientists had studied 4 giant planets through telescopes for centuries. They had learned a lot about the planets, but even the most powerful telescopes did not show many details of these distant worlds. Scientists wanted a closer look. They knew it was impossible to send astronauts that far. Astronauts have never traveled beyond our own moon. A trip to the giant planets would be thousands of times farther and would take several years. But a robotic spacecraft could make the long journey and send back pictures and information to scientists on Earth. The mission was so important that 2 spacecraft were built, Voyager 1 and Voyager 2. Scientists decided to send 2 spacecraft so that if one broke down on the long trip, there would still be one left. The Voyagers were not very big. Each one was about the size of a small car. They would carry special cameras with telescopic lenses to take close-up pictures of the giant planets and their moons. Other instruments would measure ultraviolet and infrared light, invisible to normal cameras, to provide information about the compositions and temperatures of the planets. During their long trip through space, the Voyagers would be controlled from Earth. Scientists would follow radio commands to the spacecraft, telling them what path to follow, what to photograph, and what to send back information. The Voyager's antennas would always be pointed toward Earth, ready to receive instructions. The pictures and information collected by the spacecraft would be radioed back to Earth. But the Voyager's radio transmitters were not very powerful, and scientists knew that by the time their signals reached Earth, they would be very, very weak. Listening for those signals would be like listening for a whisper from thousands of miles away. Several huge radio antennas all over the world would be straining to hear messages from the Voyagers. Exploring all 4 giant planets is possible only when the planets are in certain places in their orbits around the Sun. When the planets are in these positions, each planet's gravity can be used, like a slingshot, to speed up the aircraft and send it toward the next planet. Voyagers would fly to Jupiter first, and then use Jupiter's gravity to accelerate them toward Saturn. If both Voyagers were still working when they got to Saturn, one spacecraft would be sent to study Saturn's largest moon, Titan, and the other would continue on to explore Uranus and Neptune. It is very rare for all 4 giant planets to be in positions that allow one spacecraft to visit all of them. It only happens once every 176 years. The Voyager mission was a once-in-a-lifetime opportunity. In the summer of 1977, each Voyager spacecraft was launched into space by a powerful rocket. Soon, they were flying so fast that they passed the moon in only 10 hours. As Voyager 1 was speeding away, it looked back to take this picture of the Earth and moon it was leaving behind. The 2 Voyagers would have to pass through the asteroid belt on their way to Jupiter. Asteroids are huge rocks that orbit around the Sun. There are thousands of them between Mars and Jupiter, and a collision with one could destroy a spacecraft. Both Voyagers made it safely through the asteroid belt. Voyager 1 led the way to Jupiter, the first giant planet. The Voyagers sped closer and closer to Jupiter. As the 2 spacecraft approached the planet, hundreds of scientists crowded into mission control to see the close-up pictures of this faraway world. The radio signals that carried Voyager's pictures traveled at the speed of light. So although it had taken the Voyagers 1.5 years to travel to Jupiter, the photographs traveled back to Earth in only about 45 minutes. The pictures were received by huge antennas on Earth, then relayed to mission control and displayed on big TV screens. The scientists were stunned by what they saw. Jupiter has bright colors and complex patterns that scientists had never seen through their telescopes. The giant planet is covered with wide bands of yellow, orange, red, and white clouds. Violent storms whipped through the clouds. The Great Red Spot is a huge storm in Jupiter's atmosphere. Scientists had looked at it through telescopes for over 300 years, but they'd never been able to study its motion. Hundreds of the Voyager's photographs were put together to create a movie of the Great Red Spot. The movie showed the storm swirling swiftly around its center, with hurricane-force winds around its edges. Each of the smaller white circles is also a fierce, swirling storm. Although the white storms look small next to the Great Red Spot, some of them are as big as the Earth. Jupiter has many moons that circle around it like miniature solar system. The Voyagers discovered 3 new moons and took the first close-up photographs of many others. Jupiter's moon, Callisto, had been hit by meteorites for over 4 billion years. Each of these collisions left a crater in Callisto's icy surface. Some of the craters look very bright. These are the newer ones. Each collision sprays fresh ice over the surface, and the freshest ice is the brightest. Long ago, a very big object, maybe an asteroid, crashed into Callisto. The moon's icy ground wasn't strong enough to hold the shape of the huge crater left by the impact. Callisto's surface sagged back into its original shape, and now all that's left is a bright patch of ice and a series of faint rings formed at the time of the collision. Scientists expected most of the moons in the solar system to look like Callisto, dark, frozen, and covered with craters. They were shocked when they saw the pictures of Io, another of Jupiter's moons. There were no craters, and its surface looked orange and splotchy. At first, Io was a complete mystery. But then, one picture showed something completely unexpected. A volcano erupting. There are active volcanoes on Earth, but scientists did not expect to find them anywhere else in the solar system. 9 volcanoes were erupting on Io when the Voyagers flew past, some throwing hot gas hundreds of miles high. There are no craters on Io because lava from the volcanoes flows over its surface and fills in the craters. The cooled lava contains the chemical sulfur, which gives Io its orange, yellow, red, and black colors. Europa is ice to Io's fire. This moon of Jupiter surprised scientists too. It is covered with a very smooth, very thick layer of ice. The lines on its surface are cracks in the ice. Fresh ice oozes up through the cracks. Scientists were astonished to learn that there might be an ocean beneath Europa's icy crust. Imagine an enormous ocean of water on a distant moon of Jupiter. 15 years later, the Galileo spacecraft would confirm this amazing discovery. Like Callisto, Europa had been hit by thousands of meteorites, but there are very few craters left on its surface. Europa's layer of ice must have once been mushy, or even liquid, and erased the craters. For hundreds of years, scientists thought that Saturn was the only planet with rings. Then, the Voyagers discovered a thin ring around Jupiter. The ring could not be seen from Earth. Even the Voyager's sensitive cameras could barely make it out. The ring is made of small dust particles that are circling the planet. But where does the dust come from? The Voyagers discovered 2 tiny moons at the edge of the ring. Scientists think that meteorites hit those moons and knock dust off their surfaces. The dust goes into orbit around the planet and becomes part of the ring. The Voyagers relayed more than 30,000 photographs of Jupiter and its moons back to Earth. As scientists settled down to study the patterns, the twin spacecraft began their 2-year trip to the next planet, Saturn. Saturn is the second largest planet in the solar system. Only Jupiter is bigger. But, although Saturn is big, it is very light. It is not like a big rock. A rock would sink in a bucket of water. If you could find a bucket big enough, Saturn would float in it. When astronomers looked at Saturn through telescopes on Earth, they saw a yellow, hazy planet with 3 beautiful rings. But as the Voyagers got closer and closer, they showed Saturn as it had never been seen before. The planet had broad belts of brown, yellow, and orange clouds. Its striped atmosphere reminded scientists of Jupiter, but the colors weren't as bright, and the bands weren't as sharp. High winds howl through Saturn's atmosphere, blowing much faster than any winds on Earth. Jet streams near Saturn's equator can reach 1,000 miles per hour, and the Voyagers discovered wild, swirling storms, like those in Jupiter's atmosphere. Saturn's famous rings are made up of countless pieces of rock and ice in orbit around the planet. If you could scoop up all the particles in the rings, you would have enough rock and ice to make a medium-sized moon. Scientists think that the rings may be what's left of a moon that was shattered by collisions. The Voyagers were also part of an experiment to learn more about the rings. Scientists had the spacecraft send radio signals that would have to pass through the rings on the way back to Earth. The radio signals changed a little bit as they went through the rings. By studying these changes, scientists learned that pieces of rock and ice that make up Saturn's rings come in many different sizes. Some are as small as grains of sand. Some are as big as trucks. From Earth, Saturn appears to have 3 broad rings. The Voyager's pictures seem to show thousands and thousands of rings. Other instruments on the 2 spacecraft showed that the rings are all part of a huge sheet of particles. There are no completely empty gaps. The thin sheet starts close to Saturn's cloud tops and stretches out 40,000 miles. 3 very faint rings orbit outside the main sheet. The Voyagers discovered a very small moon, invisible from Earth, at the outer edge of the main sheet of rings. This moon, like the rings themselves, is probably a piece of a larger moon that was shattered when it was hit by a comet or asteroid. There are other small moons like this one that help shape the rings and sweep the edges clean. The solar system can be a dangerous place. One of Saturn's moons, Mimas, barely survived a colossal collision. The collision left an enormous crater 80 miles wide, with a mountain at its center that is higher than Mount Everest. If the collision had been much harder, Mimas would have split apart. Another moon, Hyperion, is probably a piece of what was once a larger moon that did break apart. Most of Saturn's moons are icy balls that were formed at the same time as the planet, but Phoebe is different. It is probably an asteroid that came too close to Saturn and was captured by the pull of the planet's gravity. The photograph is blurry because Phoebe is small and Voyager was far away. Titan, Saturn's largest moon, fascinated scientists. Before the Voyager mission, it was the only moon in the solar system known to have an atmosphere. From Earth, scientists had detected methane gas around Titan, but they could not tell whether there were other gases in its atmosphere. Scientists sent Voyager 1 on a path that took it very close to this unusual moon so they could learn more about it. When the spacecraft arrived at Titan, it found a thick orange haze covering the moon. Titan's atmosphere is very thick, more than 1.5 times as thick as the air on Earth. It is made up mostly of nitrogen gas, just like Earth's atmosphere. But unlike the air we breathe, Titan's air has no oxygen in it. What is below the orange haze? Voyager 1's cameras could not see to Titan's surface, but its other instruments sent back clues. The chemical ethane is as abundant on Titan as water is on Earth. Scientists think that there might be ethane rainstorms, and maybe even ethane rivers and ethane lakes on this distant moon. Because Voyager 1's path took it so close to Titan, it was not able to go on to Uranus and Neptune. Instead, the spacecraft headed up and out of the main plane of the solar system. Voyager 2 was on a path that allowed it to visit the last 2 giant planets. Using Saturn's gravity like a giant slingshot, Voyager 2 said goodbye to its twin and headed to Uranus alone. Uranus is so far away that it took Voyager 2 more than 4 years to travel there from Saturn. The spacecraft was still 150 million miles away when it took this picture. Because Uranus is so far from the Sun, it does not get much heat or light. It is a cold, dark planet. Taking pictures at Uranus is like taking pictures at twilight on Earth. As Voyager 2 approached Uranus, scientists had to adjust its cameras to take photographs in this dim light. The spacecraft got closer and closer to the planet, but all the pictures relayed back to Earth looked the same. Uranus's pale blue atmosphere was almost featureless. It does not have streaming bands of color or swirling storms like the atmospheres of Jupiter and Saturn. Voyager did measure strong winds, but they were not as strong as the winds on the other 2 planets. Uranus's atmosphere is made up mostly of hydrogen and helium gas, like the atmospheres of Jupiter and Saturn. But it also has small amounts of methane. It is the methane that gives Uranus its blue color. Though this pale blue planet looks calm and peaceful, scientists think it had a violent past. Early in its history, Uranus was probably hit by a huge object, maybe a comet the size of Earth. The collision was so violent that Uranus was knocked over. Now, the planet lies on its side. As it orbits around the Sun, first its south pole, then its north pole point toward the Sun. The same year that the Voyagers were launched, scientists looking through telescopes on Earth discovered 9 narrow rings around Uranus. When Voyager 2 arrived at the planet 9 years later, it found 2 more. Uranus's rings are very different from both the faint ring around Jupiter and the broad sheet of rings around Saturn. The rings of Jupiter and Saturn have many tiny particles in them. Uranus's rings seem to be made up mostly of big chunks of rock and ice the size of boulders. Several clues suggest that the rings might be much younger than Uranus. A missing moon, maybe broken apart by an impact, might have disintegrated to form the chunky rings. The rings are also much darker than those of Jupiter and Saturn. The boulders in Uranus's rings are as black as charcoal. The picture below, and a picture like it from Saturn, gave scientists a clue to the mystery of what holds a ring together. Because of Voyager's photographs, scientists now know that particles can be held in the shape of a ring by two small moons, one on each side of the ring. Each moon's gravity pulls on the particles in a kind of tug-of-war, which keeps the particles in a ring between them. The Voyager showed that moons and rings are closely related. Not only can rings be held in place by small moons, but the rings themselves may be what's left of moons that were shattered by collisions with comets or asteroids. Before Voyager 2 visited Uranus, astronomers found 5 moons around the planet. They did not know how big these moons were, or what they were made of. In just a few hours, Voyager discovered 10 new moons. It found that Uranus's moons are made mostly of ice and rock, and that even its largest moons, Titania and Oberon, are only half the size of Earth's moon. Miranda is the closest moon to the planet. It looks like a giant jigsaw puzzle whose pieces were scrambled. Part of its surface looks old and cratered, and part of it looks young and very rough. There are ice cliffs 10 miles high and canyons 10 miles deep. Scientists now think that partially melted ice pushes its way to the surface, creating Miranda's patchwork appearance. Voyager 2 flew past Uranus very quickly. Most pictures of the planet, its rings, and its moons were taken in only 6 hours. But those 6 hours gave scientists their first real look at this pale blue planet. After traveling nearly 3 billion miles, Voyager still had 1.5 billion miles to go before reaching Neptune, the last giant planet in our solar system. Voyager 2 had been traveling for 12 years. The aging spacecraft had survived its long trip through space and was finally nearing Neptune. There was great excitement in mission control. Scientists had waited a long time for a close look at this mysterious planet. Voyager did not disappoint them. The very first close-up pictures revealed a moon that had never been seen before. It was small, dark, bumpy, and orbiting very close to Neptune. The moon looked as if it had lived through many collisions. Voyager 2 would discover 5 more small moons before it left Neptune. Voyager's next pictures brought another discovery. There are rings around this planet too. 2 are narrow and 2 are broad. The particles that make up Neptune's rings are small, like those of Jupiter's rings, but they are also very black, like the boulders circling Uranus. Neptune's rings are unusual because some parts of them are thicker than others. The particles in the rings are not spread out evenly. Scientists think that the dust in the rings could be kept in clumps by the pull of 2 small moons. Scientists expected Neptune to be a lot like Uranus because the 2 planets are about the same size and are very, very far away from the Sun. But Voyager's pictures surprised them. Neptune's atmosphere has wild storms, like those on Jupiter and Saturn. This cold, blue planet has violent weather. One huge storm was named the Great Dark Spot because it reminded scientists of Jupiter's Great Red Spot. Winds near its edges are the strongest measured on any planet, over 1,400 miles per hour. Voyager 2 flew closer to Neptune than any other planet, skimming only 3,000 miles above the tops of its clouds. The white clouds in Neptune's atmosphere look like high, thin clouds on Earth. You can see their dark shadows on the cloud layer below. From the shadows, scientists figured out that the white clouds are floating many miles above the others. Voyager's path also took it very close to Neptune's rings. As it passed the rings, it was hit again and again by tiny dust particles. Even though the particles were very small, they were moving so fast that Voyager could have been damaged. But the bombardment only lasted a few moments. and the little spacecraft made it safely past. Voyager 2 raced toward its last target, Neptune's largest moon, Triton. Very little was known about Triton, but observations from Earth led scientists to believe that it might have an atmosphere. Voyager 2 found that it does. Triton's atmosphere is made of the same gases, nitrogen and methane, as the atmosphere of Saturn's moon, Titan. But Triton's atmosphere is very, very thin. Voyager's cameras could easily see through it to the moon's surface. Most moons are formed with their planet, so they orbit in the same direction as the planet spins. Triton orbits Neptune in the wrong direction. This makes scientists think that Triton was formed somewhere else in the solar system, but came too close to Neptune and was captured by the planet's gravity. After Triton was captured, the forces pulling it toward Neptune may have heated the moon and melted it. It is possible that for 1 billion years, Triton was a liquid moon. Today, Triton is the coldest place in the solar system. Its temperature is 390 degrees Fahrenheit below zero. Its surface is completely frozen. Parts of Triton are covered by ice caps. At first, scientists couldn't explain the dark streaks they saw against the pale ice. But as they looked at more pictures, they saw that dark jets of ice and gas were shooting up from the surface, then were being carried sideways by the wind. These jets, called geysers, occur when liquid below the surface explodes up through weak spots in the ice, like a warm soft drink when you pop open the can. Some geysers may erupt for months, spraying ice and gas miles into Triton's thin atmosphere and leaving dark streaks on its icy surface. Ice geysers had never been seen before. This discovery on the coldest moon in the solar system was an exciting end to a 12-year adventure. 3 days after leaving Triton, Voyager 2 was 3 million miles from the moon. As it sped away, it gave scientists this last look at Neptune and Triton. It was not long before the last giant planet was just a dot in the distance. The Voyagers are still traveling. Since leaving Saturn, Voyager 1 has been heading north out of the solar system. Voyager 2 is now heading south. Although the Voyagers are no longer taking pictures, they are still collecting data. They will continue to send information back to Earth until about the year 2020. Both spacecraft are studying the solar wind, high-energy particles that stream out of the sun. And they are searching for the edge of the solar system, the place where our sun's influence ends. The Voyagers won't stop there. They will continue into the empty space between the stars. Although they are traveling at more than 35,000 miles per hour, neither spacecraft will come near another star for thousands and thousands of years. It is very unlikely that either Voyager will be found by space travelers from another world. But just in case, each carries a message from its home planet. A copper record attached to the side of each spacecraft contains pictures and sounds from Earth. It begins, "This is a present from a small and distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings." The Voyagers are still traveling, heading toward the stars, carrying a message from all of us. The Voyagers completed their remarkable tour of Jupiter, Saturn, Uranus, and Neptune more than 15 years ago. Their amazing discoveries changed what we know about the giant planets, their moons, and rings. Since the Voyager mission, 2 other spacecraft have visited the outer solar system. The Galileo spacecraft arrived at Jupiter in 1995. It explored the planet and its odd assortment of moons for almost 8 years. Galileo confirmed what the Voyagers suspected. Europa's icy surface hides an ocean of water. It also found hints of salty oceans beneath the surfaces of 2 other moons, Callisto and Ganymede. In 2004, the Cassini spacecraft arrived at Saturn. It settled into orbit to study the planet in its magnificent rings. Cassini even dropped a small probe into Titan's hazy orange atmosphere. The Huygens probe drifted down to Titan's soggy surface. It sent back the first photos of the moon's hidden landscape. The Voyager's stunning photographs showed that our solar system is much more interesting and beautiful than anyone imagined. The chart on the next page shows what we know about the giant planets today and compares them to our own planet. Thank you, Young Artist Academy, for giving our youth a platform and for giving me a chance to share an educational opportunity during these pandemic school closures. God bless you all and stay safe.